What's up, all you badass mathematicians? So today we're going to continue on talking about limits. So remember from last time, when we're talking about limits, we first need to determine whether or not the limit actually exists. And the way we can tell if the limit exists, so I guess limit exists, question mark. So this will be the case if the limit as x approaches some value we'll call c from the right of f of x is equal to the limit as x approaches that same value from the left. So as we're approaching our value of interest, where we're checking if the limit exists, coming from either side, regardless of which direction we come from, the limits should ultimately agree, whether or not there's actually a value at c. So it's also important to note f of c doesn't have to exist. Meaning, c doesn't have to be in the domain of f for the limit to exist at c. So now I have three examples that we're going to run through and try and figure out if the limit exists. So for A, first thing I need to figure out is whether or not the limit exists. And then I can actually say what the limit is if it does exist. And so figuring out if the limit exists, so let's say we're interested in the limit as x approaches 0 of f of x. And let's call this function f. So first thing we want to do is check the limit as x approaches 0 from the right of f of x. So approaching from the right hand side, it looks like maybe we'll call that 1.2 is the value. And the limit as x approaches 0 from the left of f of x. Again, these are just rough estimates. Ideally, I'd have actual values to be able to deduce what these limits actually are. So approaching from the left-hand side, it also appears that our function is approaching 1.2 as we approach 0 from the left-hand side. And since our left-hand side and right-hand side agree, so equal. So that means that we can conclude that the limit as x approaches 0 of f of x exists, and it's equal to 1.2. So next we're going to move on to B, and similarly here we're trying to figure out if the limit as x approaches 0 of f of x exists and figure out its value. So in this case, let's use a different color. So the limit as x approaches 0 from the right hand side of f of x. So let's call this maybe 2.1. This should be from the right. And then the limit as x approaches 0 from the left of f of x. Is equal to, let's call that 1. So what we see from these two is that they're not equal. And since the left-hand limit and the right-hand limit do not agree, then what we can say is that the limit as x approaches 0 of f of x in this case does not exist. That's what DNE stands for. It does not exist. So this would be the solution in this case. We conclude that the limit does not exist. And now let's move on to our third and final example. So first we need to figure out if the limit exists. Let's use red for this example. So check the right hand and left hand limit. So again, we want limit as x approaches 0 of f of x. So the limit as x approaches 0 from the right hand side of f of x. So as we're approaching 0, our y values keep on increasing without any cap on its value. And since it keeps on increasing, we're going to say that this limit actually tends to infinity. Now, this might be a point of confusion. Well, actually, let's continue on to the left-hand side. So the limit as x approaches 0 from the left-hand side of f of x is equal to, so it appears when we're approaching from the left-hand side, as we approach 0, our values are also uncapped. So it keeps on increasing and increasing. So we would also say that from the left-hand side, our limit tends to infinity. So now it seems that our right-hand limit and left-hand limit agree. So it seems that the limit does exist. But we need to be careful. Why are we saying that that the limit from the left and the right are infinity? So we really need to think about what this infinity is representing. And what it's representing is that there's actually uncapped growth. Meaning closer and closer as we approach 1, we're going to have some y value. As we approach 0.1, we're going to have a much larger y value. As we approach 0.001, it's going to keep on growing. And as we keep going to 0, we're going to keep getting larger and larger y values. So by definition, this actually means that there is no limit as we approach from the right, and there is no limit as we approach from the left. So this is something that is sometimes a confusing topic on infinity, because a lot of people say, oh look, they agree, so the limit exists. So when you're solving this type of problem where the limits do agree, we still want to give that information and say, hey, our limit in this case is actually uncapped in the positive direction. As you approach 0 from either side, you're going to keep getting larger and larger values. But it's also important to remember that ultimately our limit does not exist, because infinity is representing this increase in value as we're approaching our c value 0. So although our right hand limit and our left hand limit agree here, and we do write down our specific information that the limit tends to infinity, we need to also keep in mind that this by definition means our limit does not exist. There is no finite value that's capping our behavior at our specific x value. So that's all I have for today. Thank you for listening, and please leave any feedback that y'all have, because that'll help me improve my videos. Thank you.